Welcome back, all of you, on day 3, session 2. So, for this session, we have with us Dr. Sanjay Patel, currently working as a head of the Department Automobile Engineering, ADIT. He has done Bachelor of Engineering from BVM Engineering College, MTech in Automobile Engineering from VJTI, Mumbai, and also hold a PhD in Mechanical Engineering. He has 20 years of teaching experience. During his teaching career, he has published more than 15 research papers in various national, international journals and conferences. He has guided many undergraduate students projects, also 5 PhD students and many more. He is also reviewer board member and member of review committee in national and international journals. As a coordinator, he has organized more than 5 FDP and STTP funded by various societies. He has also delivered many expert talks in various colleges and universities. Under his guidance and leadership, ADIT team were championed 2 times in All India Electric Two-Wheeler Design Competition organized by SAE India. He has also lifetime members for various societies. So I welcome you, sir, on this FDP, Automobile Engineering, Past, Present and Future. As an expert speaker, I request you to take the charge of this session and welcome, sir.
Thank you very much for very elaborative introduction. So I hope I'm audible to everyone. Am I audible?
Yes, sir.
Yeah, thank you. Thank you. Yeah, so good morning again to everyone. And as a coordinator also, we have met before a couple of days, and today it's my duty to deliver a talk, because last time in last FDP also I could not deliver a talk due to some other engagements. So I thought to have interaction with you all with a particular topic. So in last couple of days, all the speakers are dealing with different topics, which are some of the topics are so far untouched in few FDPs. So we thought of taking few new topics also. If you talk about past, present and future of automobile engineering, the topic which I am going to cover, it was there in past, it is currently in the market, and future is also the same. So it is like future continuous tense of English statement, perfect tense, right? So it's not a new technology, but it has entered or penetrated in the market recently, and government is fond of all these things. So without wasting much of time, I will share the screen. Is it visible, the screen? Fine. Fine. So the topic which I'm going to cover is future scopes and challenges in electric vehicle technology. Now, the electric vehicle technology is not very much new in the market. Believe me, before 100 years, it was started. Now, if it was started before 100 years, why the penetration is not very much in the society? That is the main question. So in my presentation or in my talk, mainly I'm going to cover the requirement or need of electric vehicles. That is very much essential. Then some basic technology related to EVs and batteries. because we mechanical or automobile engineers are not very fond of touching electrical or electronic part, right? We usually feel hesitant in that. But I will cover few technology or few parameters related to batteries, and then government policy related to electric vehicle technology. So many states have already declared their electric vehicle policies. So I'm going to cover the electric vehicle policy related to government of Gujarat, right? So this will be the part which I'm going to cover, these 2 or 3 points. But believe me, when we talk about electric vehicles, there are so many concepts and misconceptions in the market. So as far as possible, we will try to cover all these concepts as well as misconceptions. And you must have felt that whenever you talk about EVs, if you are, let us say, if 10, 15 people are standing with you, and whenever you start talking about EVs, you will find lots of questions bombarding in front of you, right? So everybody is talking about questions, but there are no clear-cut answers so far related to EVs. So I don't claim that I know everything, but whatever I have, whatever knowledge I have, or whatever information I have related to electric vehicles, that I'm going to share with you. So we'll start with the scenario, automotive scenario in Indian market. Indian market is basically comprises of two-wheelers, three-wheelers, passenger four-wheelers, and commercial vehicles. Now, as Professor Agnes has already mentioned about the winner of All India Electric Two-Wheeler Design Competition, this photo is about the same. This project was developed by our students, and it has got first prize in India, right? So automotive scenario, as I said, it is divided in these many categories. Now, yeah, this is of course before the lockdown. This data is before 2019, because last 1 or 2 years, every industries, they are feeling some pressure in the Indian market or worldwide. So looking at this, don't try to remember the numbers. I just want to highlight that 77% of Indian market, it comprises of two-wheelers, right? And the rest all, it is about passenger vehicles, three-wheelers, and four-wheelers. So India have very good scope in two-wheeler technology ahead, right? The society in which we live, we used to say that har ghar mein ab to vehicle ho gaya, right? But actual data, it shows something else. If you talk about the vehicle penetration per 1,000 people in India, you just look at this number. Don't try to look at all the numbers. In India, only 7 cars are there per 1,000 people. This is very surprising. Otherwise, we used to say that ab ghar ghar mein gaadi ho gayi hai, but that is not true. The data showing is something different. Buses, it is only 0.7 per 1,000 people in India, and two-wheeler, it is 43. So there are lots of scopes ahead in Indian market. Now, why I'm going to go through this slide, customer preferences for buying new vehicles in India, the relevance is very much correct. I will show you the relevance, because in India we talk about cost and fuel efficiency much, right? So all the rest of the things, brand image, sell service, resale value, comfort of buying, all this is coming later stage. But whenever we go for buying a new vehicle, we talk about cost of vehicle and fuel efficiency of vehicle. Why I am touching this portion? The reason is, it is there in the next slide, because when we will try to move towards electric vehicles, right? The question which we are asking is very simple, and I will tell you that nobody is going to ask relevant question in the market. Fine. So please try to remember that cost of vehicle and fuel efficiency, these are the two most important parameters as far as Indian market is concerned. Fine. So I will come back to this slide again. Why I will tell you. Now, before we move or jump towards electric vehicles, there are some untouched sections in automobile engineering which require exposure. And whenever we talk about advancement, people are always talking about electric vehicle only, right? But advancement is not only in terms of technology related to engine or electric vehicles. It is related to so many things. It is about different alternative fuels for vehicles. Definitely electric vehicle technology, which will be the part of our discussion today, which may be related to two-wheeler, three-wheeler, four-wheeler, and any other kind of vehicles. Autonomous vehicles, definitely artificial intelligence based vehicle nowadays booming in the market. Vehicle interiors, not very much touch in the category, but yeah, there is a scope. Smart transportation, logistic, vehicle modifications, surveying and insurance. In the morning, Basan sir has discussed about insurance and all this. Automotive maintenance and testing, automotive ergonomics, all vehicle scrap policy newly introduced by government, and automotive safety, that is vehicle safety and road safety. All these are the topics related to automobile engineering in which lots of advancements are there, and it is continuously the advancement is required. But we will be touching about electric vehicle technology, right? So if you look at the transformation from past to future, earlier automobile was only about glass, rubber and plastic. That's all. No electronics, no artificial intelligence, nothing. But nowadays it is more of electronic controls, microprocessor based, artificial intelligence, and definitely the more and more electric and electronics components. Now, why electric vehicle technology? See, whenever we ask about this question, right? This is online session. So one of the disadvantages is we can't have much more interaction through online session, right? So if you all are faculty members, if you are going to ask this question to your students, or if you are going to ask this question to your colleagues or anybody, definitely all will say that due to pollution, we want to move towards electric vehicle technology, right? Due to pollution in India, we want to jump towards EVs. That is absolutely correct. Whenever somebody is discussing or asking, your first answer should be due to pollution, the government or the people, wise people like us, should be concerned about EVs, right? But whether actually it is reflecting or not, that is a question. So I will go back to that slide. When the customer preferences for buying new vehicle, it was cost of vehicle and it was efficiency. Now you tell me, if you are going to buy a new electric vehicle, you are going to a showroom. How many of us, if I say you, that means we people, right? I'm not pointing out you only, it is we people. How many of us are asking about reduction in the pollution? Are we asking that this vehicle is giving how much reduction in the pollution? This vehicle is giving how much reduction in the pollution? No, we are not asking that. That means actually we are not concerned about pollution, but we pretend to be like that. Ultimately, our first question, whenever we are going to showroom, our first question is about cost of vehicle, about speed, and about range of vehicle. That is always the first question we are asking, right? So now you can understand that the reduction in pollution, it should not be the concern of government only, it should be the concern of we all people, right? So whenever there are scopes, there are definitely challenges, and why government is putting so much emphasis on electric vehicles, that we will look at in the next few slides. Yes, so the first part I'm covering is why we need to go for EVs. As we all know, and as a wise person of or as a wise citizen of India, we should be concerned about pollution. So harmful pollutants, global warming, air quality degradation, these are the main reasons we should go for EVs. depletion of fossil fuels, yes, definitely people will talk about what if in the next 10 or 15 years, if there is depletion of fossil fuels, if petrol and diesel is not available, what we should do, right? And national security in terms of energy independence. Now, this is more of concern because energy independence, if we are going for any fuel, any alternate fuels other than petrol and diesel, other than conventional fuels, whether it is biodiesel, whether it is CNG, whether it is LPG, solar, then biofuels, any biofuels or electric vehicles, we don't have to rely on other countries. Remember, petrol and diesel we are importing from other countries, so we need to rely on those countries. But if we are going for any other options, we don't have to rely on other countries. In that sense, we will be energy independent, right? Definitely, if we are going for EVs, still people are importing batteries and other parts from the other countries. But in that sense, we can make those components itself in our country, itself in India. So make in India, you can promote through that. And petrol and diesel, we don't have any other option, right? We have to compulsory import it mainly from Gulf countries. Fine. So because of all this, we need to go for EVs. Implementation barriers. That means what are the challenges? I mean, if everything is goody-goody, we all talk about pollution and everything, then where are the problems? The problems are lying in few things. One is codes, standards and regulations. So far, by government, it has not been decided exactly, codes, standards and regulations, but government is moving towards that. Lack of charging infrastructure, if we talk about EVs, yes, definitely, but in few months or few years, we will find it so many charging stations. So we are moving in towards that. Safety, definitely safety is a concern because safety norms are not defined exactly so far. And low oil prices, that means, this is very interesting point, low oil prices, that means if from tomorrow morning, somebody will say that petrol and diesel is available with, let us say, 25 rupees per liter, which is a dream, right? Which is not, let us say, possible. But if still, if we think that from tomorrow morning, if petrol and diesel is available with 25 rupees per liter, how many of us will go for EVs or any other alternatives? That is a big question mark, right? So yeah, it is a challenge. But currently, when we talk about EVs, the main challenges available are codes, standards and regulations and lack of charging infrastructure. If government can work on this, then definitely any state of India can move towards EVs, right? So we'll keep these things in our mind. Now, if we start talking about EVs, the first and foremost thing, just to come in the rhythm, the advantages of EVs, of course, we all know, but I will quickly cover all these points. Zero emission. It is not about reduction in pollution. It is zero pollution, right? So very much helpful for the society. High efficiency. Believe me, EVs are highly efficient than ICE vehicles. ICE vehicles, many of you might be knowing, IC engine vehicles are known as ICE vehicles, right? See, why I'm touching some basic parameters also, because many of you are teaching these courses, so they all are expert in this, but many teachers, their area is different, their area of working or their area of research is different. So they might not be knowing about the basic terminologies. So I will also try to cover all this. So it is ICE vehicles. In corporate terms, it is ICE vehicles, IC engine vehicles. So nowadays it is ICE versus EVs, right? So high efficiency, EVs are always highly efficient than ICE vehicles. If you talk about IC engine vehicles, the efficiency is around 20–30%, right? If you talk about thermal efficiency or any other efficiency, it is about 20–30% maximum, 35% maximum. But if you talk about EVs, efficiency is mainly related to motors, right? So highly efficient motors, like 80–90% of efficiency we can get. So in that sense, EVs are highly efficient than ICE vehicles. Quick torque generation because of battery and motors. Because of these motors attached, it will give you very high torque. Right? It is like once you start it, it will start moving immediately, right? And attached to each wheel, that means we are attaching normally these motors and everything to each wheel. That means automatically it becomes like a four-wheel drive, right? Which is not possible in ICE vehicles in each and every case. But this will become automatically a kind of four-wheel drive. Of course, it depends upon every time the kind of model you have. The main disadvantages so far is the batteries used in EV. The range is the biggest problem. With a single charge, you can drive your vehicle. If you talk about four-wheeler, you can drive your vehicle for, let us say, 200, 300 kilometers, right? India is a very big country. So for a four-wheeler, this is a little concern. For a two-wheeler, it is available with 50, 60 or 70 kilometers with a single charge. So that technical term is called range. So if somebody is asking that what is the range of vehicle, that means how many kilometers you can drive with a single charge, right? So for a four-wheeler passenger car, it is normally 200 to 300 kilometers. For a two-wheeler, it is around 60, 50, 60, 70, 80, 90 kilometers. Most of the batteries have to be replaced at 1000 charge cycles. Another term is cycle. If somebody is asking that how many cycles for a particular vehicle, that means for how many times you can charge or discharge your battery. If it is 1000 charges, it means you can charge your battery for 1000 times, right? Let us say you are charging your battery every day, for example. If you are charging it every day, it means per year it is 365 cycles. So if in a brochure or if in everywhere, if it is mentioned that 1000 cycles, it means in that condition, your battery life will be around 3 years. But we are not charging our batteries every day, right? Depending upon the usage. So you can calculate accordingly that for how many years your battery will last for that. And definitely lack of charging infrastructure. So all these points we will cover. And as I said, that I will try to cover some battery terminologies and some battery parameters, very interesting parameters, because we are not fond of it many a times. Coming to the components of electric vehicles, apart from the driveline and everything, apart from steering, brakes and everything, the main is battery, which is a main power source of vehicle, the charger, battery charger, motor and controller. If we take it broadly, these are the four major components of any electric vehicle system, right? Apart from this, as I said, steering, suspension, brakes, everything will be there. But this is like a big toy, we used to say. Now, we will start discussing about some technical points. So, why so much of interest in EVs, right? The first reason, as we said, EV is very energy efficient, almost 4 times. And second, it has less number of moving parts. Because in EV, there is no engine, there is no clutch, there is no gearbox. All these parts are absolutely eliminating. We are eliminating, right? So we are eliminating lots of moving parts. So 50 times less moving parts. So all the noise reduction will be there due to less moving parts. If you look at this, 14 of 20 most polluted world cities in India, right? So due to this pollution, we need to move towards EVs. Now see, the references I have taken, let me clarify. The references I have taken, one is from the books available. Second is our NPTEL sources, which I have also mentioned. NPTEL, as you know, that it is very much source of learning. It is a very good learning platform, right? So few slides I have taken it from NPTEL, and when EV policy will come into picture, it is the government document, right? NOx emissions, coming back to this, 36% and 20% particulate matter emissions. So due to all this, we need to move towards EV. Now that is clear in our mind. Now, if, as I said, if we all talk about goodies, then why there is a problem in switching over to EVs? For that, the battery is the main concern. People will always talk about battery. What is the life of battery? Which parameters will affect the battery life, right? What is the cost of battery and all this? So we will try to cover few points. We will start with the basic, you can say, unit. Many of us are not aware. So watt hour is the unit of energy mainly, and this we are using it for battery. With a simple example, if a 30-watt bulb we are using for 1 hour, it will consume 30 watt-hour of energy. But for vehicle, watt-hour is not enough. So for vehicle, normally we are using kilowatt-hour, right? For a two-wheeler, normally we are using battery of 1, 2, or 3 kilowatt-hour. For a three-wheeler, normally the range is 3, 4, 5 kilowatt-hour battery. And for a four-wheeler passenger vehicle, it ranges from 15 kilowatt-hour to 30 kilowatt-hour, right? In normal situation. The companies like Tesla, high-end vehicles, they are giving the capacity of battery as high as 100 kilowatt-hour also. Very, very costly batteries, right? So I hope you understand the meaning of watt-hour. Now, 3 points we will cover. One is watt-hour. Second is watt-hour per kg. Please keep in your mind. And third is watt-hour per kilometer. Right? It looks similar, but it is not so. So watt-hour per kg, and watt-hour per kilometer. Very interesting things we are going to cover. So 1 kilowatt-hour, as we know, 1000 watt. So if a battery is having 1 kilowatt-hour capacity, it means it can consume or it can produce 1 kilowatt-hour or 1 kilowatt or 1000 watt in 1 hour. That is the meaning, right? If we compare battery and petrol, in coming slides we will compare. It is very much interesting again that even if you compare a petrol vehicle, that means ICE vehicles or battery operated vehicles, even a petrol tank, see, when we talk about EVs, we are not using petrol or diesel tank, right? We are not using any kind of gas. So petrol tank, diesel tank or gas tank, we are totally eliminating. So if you compare the weight of vehicle or the cost of vehicle without any kind of petrol tank, without any kind of components which are there in ICE vehicles, the EV will be lighter and the cost of EV will be less than cost of petrol or diesel vehicle, provided you are not using battery in that or you are not providing battery in that, right? Because the weight of battery, if you are comparing with weight of petrol tank or diesel tank, it is very much high. Why it is very much high, I will tell you afterwards. So weight, volume and cost. These are the 3 important parameters for a battery. Now, if you simply compare, as I said, the weight, volume and cost, when we talk about petrol, you can imagine, in coming slide I will cover, you can imagine what would be the cost, what would be the weight and volume comparison of petrol and batteries, right? That we will cover afterwards. So whatever we are already aware. Now the energy density, as I said, the unit of this battery, the second part we are covering is watt-hour per kg. Now try to understand what is the meaning of watt-hour per kg. In 1 kg, how much energy in terms of watt-hour you are feeling, right? In the year of 2011, it was 80, and now in the year of 2020, it is around 300. What is the meaning of that? If you are packing 300 watt-hour energy in 1 kg, it is called 300 watt-hour per kg. So over a period of time, we are packing more energy in less weight, right? Earlier it was, the value was very low. So we are interested in increasing this number. Maybe in coming years, this will become 1000 watt hour per kg, right? If we compare it with cost, this is the cost of cell, not the battery, in dollars, right? So this cell price is increasing with increasing energy density. The reason is, with 1 kg, you are packing with the same material, but energy density is increasing, right? So material you are not adding. So ultimately the cost will get reduced, right? So as I said, our aim in the, our means the manufacturer's aim in the next coming year is 1000 watt hour per kg. Now, ultimately, we are packing more and more energy with the limited space, 1 kg, right? With a limited space. So ultimately, it is becoming like a bomb. You understand? In case of blast, it will blast like anything. So in that case, it is a disadvantage, but there is no other option by which you can increase the energy density. That is the only option by which you can increase the energy density. That more and more energy you can pack in the smaller area. It's like crackers, right? So we need to be very careful, but at the same time, we will be used to handle all these things in coming years. Because before few years, let us say before 50, 60, 70 or 100 years, we were not very fond of using petrol and diesel. But petrol and diesel, yes, I'm making a statement, petrol and diesel more dangerous than these batteries or the material of batteries. Why it is so, I will tell you. Right? So as I said, this is all what we already talked about batteries, that we are packing more and more energy, and because of that, the cost will fall rapidly, and that is the only reason. As the energy density improves, this is important statement, you will see the battery size going down for the same range, for the battery weight will go down, and ultimately the cost of battery. So if we want to reduce ultimately the cost of EVs, we need to reduce the cost of battery, because 60 to 70% of cost of EV is dominating to the cost of battery, right? So we need to increase the energy density in terms of watt hour per kg. Please remember. So what we are trying to do is, we are packing more and more energy in a smaller area, and as we are doing that, it is becoming like a bomb, as I already said, right? So now we used to have the habit of using these batteries. Now one question I have asked without taking answer from you, what is the energy density of petrol? It is about 12,500 watt hour per kg, right? And what about batteries? In the previous slide we have already seen, it is around 300 watt hour per kg. Now you imagine 300 watt hour per kg and 12,000 watt hour per kg. It is almost 40 times. So you can say that it is 40 times more dangerous, right? In case of blast, the petrol is more dangerous than these batteries. But nowadays we can handle it properly. So in coming years, we will be able to handle these batteries also. So there is not, it's not an issue, right? Now, as I said, the cost of EVs in India and energy per kilometer. So this is a very famous statement from Maruti Suzuki, that kitna deti hai, right? We always used to ask that what is the fuel economy in terms of kitna deti hai. So that was very touchy or very catchy word, very catchy slogan from Maruti Suzuki. So if you want to improve the efficiency more, it can be improved by few parameters. One is motor or controller efficiency. Second is by using better tires. If you are using better tires, definitely we are reducing the rolling resistance, and with better vehicle aerodynamics, right? And definitely we can reduce the weight. So these are the 3 or 4 parameters by which you can achieve it. I mean, you can achieve the higher efficiency. One is by improving motor efficiency. Second is better tires, vehicle aerodynamics, and lower weight. So nowadays, mainly in two-wheelers or in some of the vehicles, they are using aluminum alloys and other components because it will reduce the weight of vehicle, and ultimately it will improve the efficiency. So ultimately it will improve, you can say in other words, the mileage of vehicle sorry. Sorry for that. Right? So we talk about watt hour, we talk about energy density in terms of watt hour per kg, and third important parameter is watt hour per kilometer. Right? Try to understand watt hour per kilometer. Now this value must be higher or lower, sorry. That is the point of discussion. So how we will understand this watt hour per kilometer is size of the battery required becomes small, and if the size of battery becomes smaller, the cost will ultimately go down. So focusing on reducing watt hour per kilometer is very much important. If you say watt hour per kilometer, that means for 1 kilometer, how much energy you are consuming. So it is directly related to a kind of mileage or efficiency of vehicle, right? So if the consumption is less, it means the mileage of vehicle is more, right? In energy density, it was a little bit different. In energy density, we were interested in higher value of watt hour per kg, right? In case of watt hour per kilometer, we are interested in lower value, fine? So if you consume less energy to travel 1 kilometer, your mileage will get increased, right? So always think of reducing the watt hour per kilometer. How it can be achieved? That is a point of discussion, right? So to make electric vehicles viable in India, the first technology program, first R&D program is how much we can reduce watt hour per kilometer. Or we should start asking the question, kitna deti hai, right? So we'll talk about all these things. This we have already talked about better tires, better vehicle aerodynamics. For that, we can use different materials, lightweight materials, and these things will ultimately improve the efficiency of motor and controller. Few things are not in our hand. Few things are in the hand of manufacturer, like material of batteries, material of vehicle, and all this. What things are there in the hand of driver is the driving habits, right? So reduction or battery cost reduction strategy, as we talk about watt hour per kilometer. Earlier, for three-wheelers, it was 70 to 80 watt hour per kilometer before few years. Now we are coming at this stage that for a three-wheeler, it is approximately 45 to 50 watt hour per kilometer, right? For buses, earlier it was 1600 watt hour per kilometer. Nowadays it is around 900 watt hour per kilometer. So you are reducing the battery size in that sense. That means you are reducing the size and you are packing more energy in that, right? Now, if you are reducing the battery size, one term will come into picture. See, some more terminologies we will also discuss during this talk. Range anxiety, it is a technical term. Range anxiety, that means you are always worrying about the range of your battery. For example, you are using a four-wheeler which is having a range of approximately 300 kilometers. You want to go a place which is 275 kilometers away from you, right? So after 200 or 225 kilometers, you are always thinking about your battery, that whether it will drain out or not. If it will drain out, where I will charge it. It's like range. It's like our mobile. Every time we are thinking of battery of our mobile. Dopar ka time hai, so we will think that what if my battery will drain out. right? So these things mentally affect you, and that is called range anxiety. Yeah, it's a technical term, right? So people will always think of range and batteries, and this range anxiety will affect the driving habits also, right? So these numbers are important. Now the most awaited things, or people are talking about, every time they are talking about charging stations and all these things. So whatever information or knowledge available so far, we can discuss about this. The first and foremost thing people always talk about is swapping of battery or swapping stations, right? What does exactly it means? If some of you are not aware of swapping stations, let me tell you that it is like a LPG cylinder, right? You don't own your LPG cylinder, you have LPG connection. That LPG cylinder, the company or the owner will provide you LPG cylinder as per your requirement, right? Per month, if you require one, they will give you one. If you require two, they will provide you two. Similarly, the swapping station is a kind of concept where the people will don't buy their own batteries in one sense. In second sense, they will give their battery for charging to these swapping stations, right? It's not like on battery I will write my name and I will give it to them. No, these are coded batteries. So I will give my battery to swapping station. I will take new battery from the swapping station, and within 1 or 2 minutes I will fix it. Because if your battery will drain out, and if it is taking 1 hour, 2 hours, or 4 hours for charging, nobody is ready to wait for so much of longer time on the highways, right? If you are charging it at your place, it is okay. So charging station, or sorry, swapping station is a good concept as far as the battery reliability is concerned. Another is split battery. Now we are talking about approach for business viability for public transport. This is about public transport. Split battery. Instead of using only one battery of higher capacity, what people can do is they can buy two batteries of smaller capacity. See, every time you don't run your vehicle for many kilometers, right? Every time you don't require to travel 100 kilometers or 200 kilometers. If you are using your four-wheelers in a medium or medium city, you are traveling 30, 40 kilometers or 50 kilometers, right? So every day you are not going for 200 or 300 kilometers. So one battery you can use regularly. You divide your battery in two parts, and as and when required, second battery can be swappable. It can be charged whenever it is required. So split battery is also a good concept as far as the transportation is concerned. Battery life will be affected by fast charging at 45 degrees. This we will touch separately, right? That factors affecting the life of battery. This we will cover a little bit later. So advantages of battery swapping is, one is there is a separate business of battery swapping. So energy operator will come into picture. Many companies will establish their swapping stations. Like currently we have petrol or diesel stations of BPCL, HP, Indian Oil, and all these, right? Similarly, companies will establish their own swapping stations, right? And from that, people can charge their batteries. So more and more companies will come in that business. So one more business will get open, which is called energy operator, right? So capital cost of vehicle is less than that of petrol vehicle. If we talk about Eevees, without battery, the cost of vehicle is less than cost of ICE vehicle, because there are no moving parts. There is no engine, there is no clutch, there is no gearbox. All these we are eliminating, right? Second approach for private vehicles, that this couple of options we will discuss. See, if you have a four-wheeler with you, for example, so how many options are there to charge your battery? One option is you can charge your battery at your home with your charger. Second option available is you go to a swapping station. So far, swapping stations are not available in our market, but this is a concept. So second option is you go to the swapping station, you charge your battery, and you fit a new battery and you give your battery for charging. Third option is split battery, as we have already talked, that you divide your battery in two parts. So whenever required, you charge it accordingly. Because large battery, if you are using, it is increasing cost like anything, right? So accordingly, you can select. Earlier, it was not possible, like as per government mandate, you cannot buy a vehicle without battery. But recently, in the month of probably July or September, government has passed the mandate that you can purchase a vehicle without battery. Then according to your requirement, you can fix a battery. There will be options available. According to your requirement, you fix the battery, right? So slow charging, fast charging, all these options will be available for you. Range extender batteries. This is also another possibility. It is like the power bank of your mobile, right? Exactly similar to power bank of your mobile. That every time we don't require to charge our mobile. So if we are going out sometime, we carry our power bank. Similarly, range extender batteries may also be available for this kind of purpose. See, we are talking in simple terms. We are not going in very much detail regarding the technicalities. Third approach is conventional approach. That means you purchase a vehicle with a fixed battery as per your requirement. If you want to travel only 30-40 kilometers a day, you take it accordingly. If you need to travel every day 100 kilometers, you purchase the vehicle accordingly, right? For all this, we need some standardization. We need some standardization in terms of batteries, in terms of vehicles and all this, because it is something like if you are filling petrol in your vehicle, on every fuel station, the petrol available is same. The property is same. You are not asking about what kind of property is there, whether it will be suitable for my vehicle or not. Similarly, in a CNG vehicle, the nozzle available at different station is same, right? At CNG station, it is same. That means you don't have to worry about whether that nozzle will be fitted properly in your vehicle or not. Similarly, for charging and for chargers or for batteries, some kind of standardization are required, and that has to be from the government side. For example, if you are using mobile of different companies, for few companies, the charging jacks are different. For majority of company, it is same. So a kind of standardization has been done by the government or companies. Similarly, it is required in electric vehicles also. Now, this is something very interesting. The life of battery, it depends upon which factors. It depends upon so many factors. One is, we will talk one by one, 4 or 5 factors are there. Charge and discharge cycles. As we talk about it, that for example, if it is 1000 cycles, if you daily keep on charging and discharging your batteries or vehicle, it will be of no use in a smaller time, right? So even if it is 1000 cycles, and if you are charging your vehicle 2-3 times every day, it will reduce the life. So number of charges and discharges is very much important. Battery chemistry used, it is not in your hand. Manufacturer will give you the property or the batteries accordingly. Rate of charging and discharging, right? Higher rate will reduce the life. Usage temperature, very much important. That normally, as far as technical data is concerned, around 25 to 26 degree, if you are charging your battery, it will give you the best life. Before 25 degree, it will keep on reducing. The life of battery keep on reducing. It will affect adversely when you go up to 0 degree or 10 degree. Even at 0 degree, it may not work. If you go on higher side, 30-35 degree, it is okay. When you move towards 40 or 45 degree, it will damage your batteries like anything. And in India, 40-45 degree is very much common in the month of, let us say, April, May, June, and all this, right? So that will affect the life of battery. Operation region of charge and discharge, that means depth of discharge, or DOD. DOD is a technical term. We used to say depth of discharge. So whether you are charging your battery for how much percentage, that is called depth of discharge. And calendar life, definitely you must be aware the meaning of calendar life is, for example, if you are not using your battery for 1 year completely, then your battery will be of no use. So for every battery, the calendar life has been decided. Next is state of health, SOH. It is a technical term again. It is a measure of battery capacity remaining as compared to initial. That means you must have heard that initially, if the battery capacity is, for example, you can run your vehicle for 90 kilometers for full charge in a two-wheeler. After some time, it will become 90%, 80%. So you will not be able to utilize fully 90 kilometers, right? So that is called state of health. It is measured in terms of percentage compared to the initial capacity of battery. Another term is EOL, that is called end of life. After some time, let us say, after 75 or 80% of initial capacity, your battery will be of no use because you are using it for mobility, right? So that is called end of life. But similar battery you can use for these stationary applications like in inverters, in UPS, or everywhere. But for vehicle, it will be of no use. So these parameters or these factors will affect the life of battery very much, right? Now, state of charge, SOT, as we talked, it is a measure of percentage of battery charge. See, when you are charging your battery from 0% to 100%, 0% means fully discharged battery, 100% means fully charged battery, right? Now, you must have observed in your mobile, right? Because we are not fond of charging our vehicles. We are not observing that. So I'm giving you a simple example of your mobile. When you are charging your mobile, if you are charging it up to 80-85%, it will get charged rapidly. After, for example, 85 or 90%, it will get slowed down. It will reach up to some constant voltage, and the time required for that will get increased, right? So state of charge is also important. Now we will move little bit quickly. See, we talk about fast charge, we talk about slow charge. There is nothing like slow charge or fast charge. If I say there is nothing like slow charge or fast charge, it doesn't mean that these are not the technical terms. These are the relative terms, you understand? And for that, the technical term is C rate, right? C is we are using for charging, but the similar letter we are using for discharging. So if somebody is saying that 1C charge, what does it mean? I will tell you. If somebody is saying 2C charge, 2C rate, what does it mean? See, let us take the example of a battery, 15 kilowatt hour battery, right? For a 15 kilowatt hour battery, if you charge it fully, it will take 1 hour. If you are doing it with 1C charge, right? If the charging rate is 2C, it means you can charge or you can discharge your 15 kilowatt hour battery within 30 minutes. Means you are reducing the time for that. So ultimately it becomes fast charge. You understand? If it is 4C rate, you are charging it 4 times faster than original one. So it will take 15 minutes to charge a 15 kilowatt hour battery. On the other side, if it is 0.1C rate, that means for a 15 kilowatt hour battery, you are charging it with 1.5 kilowatt rate, right? So it will take 10 hours. This you require to understand, right? So if somebody is saying that I have a fast charging system, it means you are charging it with 2C or more than 1C rate. You understand? So for we have taken example of 15 kilowatt hour battery. So if it is with 2C, it will take half time. If it is with 4C, it will take even the quarter time. And anything less than 1C will be a slow charge, and anything greater than 1C is a fast charge, right? So if a vehicle requires power of 30 kilowatt hour, and if the battery available is 15 kilowatt hour, it is using 2C rate, right? So this is only for understanding purpose. So this we have already discussed, I think. Second life of EV battery, it means once the battery is of no use for your vehicle, what you will do? You will have to throw out your battery from the vehicle. But the same battery with lower capacity, as I said, can be used in a UPS or inverter kind of stationary kind of application also. So that is called second life of EV batteries. Right? So due to, I think, lack of time, we will not go much more in detail. Yeah, this is something because we need to cover electric vehicle policy also, government policy also. Now, there are so many questions. If somebody is saying that we are going for a swapping station, right? What if my battery is stolen? What if somebody will give me a poor battery than my original battery? What if somebody is not charging it properly and all this? So for all this, the answer is there in the smart swapping station. It is called smart swapping station. There is the role of IT people or other people in that. You can make a battery in such a way that it can be operated with codes only. You can have your unique code with your battery, that is possible. You can charge your battery with authorized chargers only, that is also possible. You can fit it in authorized vehicle only, the connected vehicle only, that is also possible. So all these things will come under the standardization, and energy companies and government may play a big role in standardization, right? Because there are lots of questions in front of all of us. Yeah. So far we have covered about some parameters and some technical things about batteries and vehicles. Now, within 5-10 minutes, I will quickly cover the Gujarat State Electric Vehicle Policy 2021. In fact, many states like Assam, like Maharashtra, and I don't remember other states, but I think Goa. So few states have already declared. Gujarat government has already declared their electric vehicle policy in the month of July 2021. Right? So what is there exactly in that vehicle policy? So I have put up the documents directly taken from EV policy, and in simple words, we will try to understand, right? Because there are again so many myths or concept and misconcept available in the market. So we are going to talk about Gujarat State Electric Vehicle Policy 2021. It becomes operative from July 2021, 1st July 2021, and it will be valid for the next 4 years, right? So government has declared their objectives, their targets and roadmaps, and incentives for customers, for manufacturers, and for infrastructure developers. So in simple words, with real data, we will discuss, right? What is the preface? We will not discuss. Yeah, what are the objectives of government? One is the transition, the state's transportation towards electric mobility. Government wants that more and more vehicles should be available with EVs. To make Gujarat a manufacturing hub for electric vehicles. It is already moving towards, I mean, Gujarat is already like hub of automobile for conventional vehicles. But now government is trying to promote as a manufacturing hub for EVs. And as per the news available, the government of Gujarat has already offered Tesla Motors 1,000 acres of land in the state of Gujarat somewhere, right? To encourage startups and investment in the field of e-mobility. and to improve the quality of environment. This is important. But for that, government needs to do all these things, 1, 2, and 3. Then only point number 4 will get satisfied. Now, what exactly there in EV policy, right? See, right now, the knowledge available with majority of people is कि भाई कितना subsidy मिलता है, right? For a two-wheeler, 15,000, for a four-wheeler, 50,000, and all these things. But exactly the meaning is little bit different. Right? What is that? I will tell you. So government is targeting first 2 lakh electric vehicles only. So if you are buying your vehicle, after 2 lakh electric vehicles, you will not get any kind of benefits. Remember that. So first 2 lakh electric vehicles will get benefit of government policies. For that, the bifurcation available is they are targeting 1,10,000 two-wheelers, they are targeting 70,000 three-wheelers, and 20,000 four-wheelers, whether it is private or commercial vehicle. So ultimately, government of Gujarat is targeting 2 lakh electric vehicles to get to give benefits, right? Now, this will be applicable to all the classes of electric vehicles, and it should be in line with Femto scheme of Government of India. Now, what is Femto scheme? It is faster adoption and manufacturing of hybrid and electric vehicles. Remember that Femto scheme is the scheme of Government of India, and this electric vehicle policy is a scheme of state government, Government of Gujarat. Right? Incentives for early adoption of electric vehicles. Every people are interested in this. Now, just pay attention. The demand incentives from the state shall be over and above any subsidies that are available from central government. So whatever subsidy you are getting from central government, this will be above and over from it. So you are entitled for both with conditions. I mean, in some of the cases it is not possible, in some of the cases it will be possible. And this subsidy will be directly given to the customers via DBT, which is direct benefit transfer. Like they will deposit the amount in the account of what you can say customers itself directly. They are not giving it to the companies or the sellers. And the incentives for all types of electric vehicles, this is very important, shall be based on the battery capacity. Please remember that subsidy available is on the battery capacity in terms of kilowatt hour. That is why it was important to discuss about kilowatt hour. So for 2, 3, and 4-wheeler, the subsidy available, the benefit available is 10,000 per kilowatt hour for all these 3. Please try to understand. But the clause is maximum ex factory price. For a 2-wheeler, it should not exceed 1.5 lakhs. If your ex showroom price of your vehicle, your 2-wheeler is more than 1.5 lakhs, you are not entitled for this benefit, right? So it should be below that. For 3-wheeler, the range is, the limit is 5 lakhs. And for a 4-wheeler, it is 15 lakhs. So keep in your mind while getting benefit for EVs, this range or these limits, right? The beneficiary can opt to get subsidy under any one scheme of state government run by different departments. The beneficiary cannot claim subsidy under more than one scheme of state government. If you are getting, it is like a scholarship for students. If you are getting a scholarship from one place, you can claim to another place, right? For 2-wheeler, as I said, 10,000 per kilowatt hour. Now for a 2-wheeler, normally we are using battery of 1, 1.5, 1.3 or 2 or 3 kilowatt hour. So accordingly you will get. For a 3-wheeler, normally we are using 3, 4 or 5 kilowatt hour battery. For a 4-wheeler, 15 to 30 kilowatt hour battery capacity. Another clause given is the maximum amount of subsidy should not be more than 40% of ex-factory price of vehicle. So if for a 2-wheeler, if the ex-factory price is 1.5 lakhs, it should not exceed 40%. There is a clause, right? So you cannot get more than 60,000 of subsidy, even if you are fixing a very high battery, high capacity battery. So this was for customers who are buying the EVs. Now, incentives for charging infrastructure. If you are interested in setting up the infrastructure, if you want to have your charging station, then these are the benefits available. If you want to have your EV charging station, you will be eligible for getting 25% of subsidy on equipments based on the capital of your equipments. So if you are getting the equipments of 10 lakh rupees, maximum 25% of subsidy you will get, and the maximum limit given is 10 lakhs per station, right? And another clause given is it is applicable to only 250 commercial public EV charging stations. Government is planning for more than 500, but right now it is that the benefit is will be given to only 250 commercial public EV charging stations, right? Then next is NOC and everything you should get. That is okay, that is fine. Petrol pumps will be allowed to set up charging stations subject to the charging station area qualifying fire and safety norms, right? If you have your own fuel station, you can establish your charging station itself on your fuel station, right? With some conditions. The government shall exempt 100% electricity duty. It is about 100% electricity duty on EV charging stations. That is the benefit they are giving. Then about license and everything, it is fine. Convergence, that means coordinated movement. Who will take care of which things, right? So the National Electric Mobility Mission Plan, NEMMP, and the faster adoption of manufacturing of electric vehicles, FAME scheme, are promoted by Government of Heavy Industries, Department of Heavy Industries, DHI, Government of India. So all these are in line with that. If you talk about state government, these three departments will be responsible for that. Ports and Transport Department, they will be the nodal department in Government of Gujarat and shall be responsible for planning, implementation and review of policy, right? Intermediate review of policy is also possible. If something is required to be revised, if something is going wrong, then intermediate policy review can also be possible before 4 years. Second department is Energy and Petrochemical Department. They will be responsible for charging stations and subsidy related to it. And third is GERMI, Gujarat Energy Research and Management Institute. They will be responsible for any kind of research, training, incubation, and other activities, right? So like this, it has been divided. Now, sometimes the interpretation from different people or different agencies is different. If there is some misinterpretation, then Ports and Transport Department, whatever their order is there, it will be final, right? So that is also, yeah, power to issue and interpret. In case of any dispute, the Ports and Transport Department, the interpretation given by this department will be final. So this is the last slide I'm showing you. It shows about the information which I have given related, I have not given related to FAME, but if right now, if you want to have information regarding how many vehicles have been sold in Gujarat or in other states, you can go through this website. The first page of this website will give you a very good map of India showing the live status of all the vehicles sold, how much reduction in pollution has been taken place, that it will show. And they will also show that in different states, what is the selling position of two-wheeler, three-wheeler, four-wheeler and everything, right? So you can go through this website. This is very interesting website of government. So we are not covering road safety. So I think that looking at the time, that's it from my side. Whatever information, whatever knowledge I have regarding this, I have shared with you. So in case of any question, you can ask. If I have answer of that, I will definitely reply. Otherwise, I will look at the matter and then I will reply you at any time. Yes, anything from? One question is, what is bidirectional charging in EV? See, bidirectional charging, this is very interesting point we will cover in 1 or 2 minutes. See, it should not happen that everything is covered in smart swapping station or smart batteries. You understand? The meaning is, it should not happen that if your battery is highly charged and if you keep your battery on charging, it will draw power in reverse manner, right? So we used to say that battery should be able to communicate with your vehicle. Vehicle or battery should be able to communicate with the grids, right? So this is very deep area. If you will try to cover, it will take so many hours also. But that is the meaning, that it should be unidirectional and there should not be any reverse flow in that, right? So in simple words, we used to say that they should be able to communicate with each other, and that is possible only with the smart technology. Yeah, anything else? Okay, no question, then that's it from my side. Thank you very much. Over to you, Yagnesh sir.
Thank you so much, sir, joining with us and sharing the information related to what are the challenges and scope in automobile engineering, especially for EV. And we have talked about the nicely present the EV policy and some technical terms related to electric battery used in electric vehicle. So, on behalf of participants and department, I would like to thank you so much, sir, joining with us in FDP. Thank you so much, sir.
Thank you. Thank you.